Hello students, the next topic is metric operation in OpenGL. So the 4x4 matrix what we have discussed earlier in the previous video, that is the homogeneous coordinate representation for a 2D as well as 3D model. Okay, this is the standard representation 4x4 matrices because whether third dimension is present or absent. If it is absent, make the third parameter as 0. If it is present, what is the actual value, you put there, you substitute there in the third parameter. Okay, so OpenGL built-in function supports for that, both 2D as well as 3D. The common function we have. Next is how to what are the matrix operations in OpenGL. So you have to write, you have to load the updated contents of the model with the help of some standard OpenGL function by making a call for the standard OpenGL function. See, initially you have to load the identity matrix. That's why GL load identity is required. If you go to see your lab programs, in all the programs we have somewhere we have written uh, before selecting the view, we have written that GL load identity. You must have seen. If you have not, just go through it. Okay, all the lab programs will be having that as a common statement. That means initial. Yeah, hope it is visible. The updated one will be brought onto the display with the help of the GL matrix mode, GL model view. This particular parameter. So this is the built-in parameter where GL matrix mode is the function, built-in function. Okay, so you can go through it. See, GL load entity, you can go through the explanation. Explanation is given in the next page, very next page of our previous discussion. I'll tell you the page number of if you want. Okay, it is just before 2D weaving. Okay, just before 2D weaving, just go through, just observe page number 25 from that document. Module 2 we are in. Okay, just go through this explanation or description which tells you about OpenGL matrix operation. So initialization that is done with the help of the statement GL load identity. Sorry, it is a function with the help of the function GL load identity. Then later on we are making a call for the model view matrix. So GL matrix mode, GL model view. This is the built-in parameter. So GL underscore model view you have to write. Just go through the description, go through the explanation which is given over there. I have already shared the document with you, so if you have any doubt you ask. So this completes all about the transformation. Next we have weaving. Okay, the last part of second model, only few concepts are there, two concepts are there. 2D weaving, about 3D weaving we'll be discussing in the next model, that is third model. For us it will be the fourth model. Okay, two-dimensional weaving pipeline is the first concept. So viewport concepts are there. uh, Basics of weaving. Once we have already discussed about 2D weaving with the help of the function GLU ortho 2D. Just recall, we have used them in the first two programs. GLU ortho 2D is the function name we have used. Okay, it takes four parameters. The four parameters are left, right, bottom and top. That is x minimum, x maximum, left and right. X minimum should be left and x maximum which represents the right side. Okay, then bottom and top. So y minimum represents the bottom position and y maximum represents the top position. Just visualize the content. So we analyze the things. Okay, you will come to know. That is for the 2D model. For the 3D model, two additional parameter will come. That is near and far. Okay, total number of parameters for the function will be 6 for the 3D model, whereas for the 2D model it will be 4 only. That's what we are going to discuss now. That is about the weaving. Okay, so definition of the viewport. First is the definition of the viewport, a graphics package that allow us to control the placement within the display window using another window which is called as viewport. Viewport, where exactly the model is displayed or where exactly the model is positioned on the display window, which is called as viewport. Okay, the size of the display window may be anything. That doesn't mean, see, if the display window contains 500 and 500 points on horizontal and vertical direction, that doesn't mean all 500 points is used to store the model or use it to display the model. You must have seen the output, right? White background will be displayed on top of the white background. First on the monitor there will be an output window displayed. Then output window will be having either white or black background. as per our previous discussion, that is lab programs, the entire 500 or whatever the points and or entire that background, white background, see, you could see the background means model that doesn't take all the points, right? All the 500 and 500 points, what you have considered to define the window, right? Only in some portion of that output window model is brought. That particular position is considered as the or called as the viewport. The next important concept is about clipping. So clipping window. The meaning of clipping. Hope you are all familiar with that, because you are familiar with the paint function, paint application, right? On any other tool, image editor. So in that image editor, if you want to crop the photo, what you will do? You will select only particular portion of the image, right? Then you will copy the content to the new file and you will save it, isn't it? So the meaning of clipping is selecting a particular portion from the model. Okay, that is what clipping is. As you can see over here, let it be the entire model. See how the model looks. Okay, this is what the model is, but clipping window, you see the size of the clipping window. Clipping window is a kind of rectangle, so you are interested only in the particular portion of the entire object. Assume it's a photo. It's a photo of a mountain. Where it is, see where the mountain starts. From here it starts. For your reference, I'll use the pen application. Okay, see from here it starts. This entire thing we are considering as the mountain. Okay, but only particular portion, this is the image, existed image, you want to select and create one more file. Only this portion of the mountain you want to display. What you are doing, you have defined a clipping window. Okay, you have first you have defined the size of the window, then you have put the clipping window over there, then selection is done. How the selection is done? As you can see, this is what the clipping window is, and you have updated the viewport. That is, in a normal case, with respect to paint application, what we do, suppose you are opening an image with the help of the paint application, you are going to select the particular portion of the image, say mountain, then you are going to cut it and paste it on a new file. But as per our computer graphics application, what we can do, there itself we can, with the help of the viewport concept, we can update the view, saying we can ignore the remaining portions of the, it looks like the image is updated. We can what we can do, we can, please try to understand, we can crop off the remaining portion of the existing model, okay, by updating the viewport. So whatever the contents are there in the rectangle are only visible on the screen, rest will be simply clipped off or cropped off. That is what the application of the viewport is, and which, that is what the meaning of the clipping is, that is selecting a particular portion and displaying onto the window by defining a rectangle, which we call as the viewport. Fine, let us continue our discussion in the next video.